Let's go.
Okay. Everyone else ready? Okay, it looks like FPGA is a much more interesting topic, choosing by the number of attendees here. But now we are going to talk about PCBs.
Lunchtime, so a lot of people.
Why did you place me right in the lunchtime? Really? Is that for a special reason? Okay. We are talking. My name is Patrick, and today I want to introduce you Joseph. The working title you've seen on the FOSDEM page is Ruby bindings for Libgerbv, because we came up with the name Joseph like 4 days ago, so I did not have any time to update it. The clever guys of you may recognize the name, otherwise just ask me later. So has anyone of seen these windows here? They are out of the Eagle, Cutsoft Eagle, Autodesk Eagle, whatever you call it. The resolution is quite bad. If you do not recognize this, these are the windows to penalize a PCB. You couldn't do the same, penalizing PCBs. If you want to order them at a PCB fab and you only have a tiny one, you add some more to get a cheaper price. You can do this in KiCad 2 using the Python scripting functionality. But what I ask myself is, why are we doing this within the EDA CAD application? Because actually tasks like penalization are CAM tasks, because they are not about your project, they are about manufacturing of your project. So this are really red stop sign for me. If it comes to penalization, adding V-cuts for the fab so that you display them where to cut your PCBs, fiducials drills of the actual PCB, because you do not want to have them on your project, but they are more a support for manufacturing the PCB. So what I ask myself is, why are we using EDA applications like KiCad, Eagle, whatever, for these tasks? I think the reason for this is that right now we have no open source CAM tools at all. If you have a tool, please shout out. Yeah, Gerber. But have you tried to draw a frame around your PCB with Gerber?
No, okay.
That's the point.
In the design then.
Yeah, Gerber is totally fine for viewing PCBs. I know a lot of PCB fabs which use Gerber because it has excellent Gerber support for visual proof of the PCBs. But what I discovered is that actually Libgerbv, the library behind Gerber, is actually able to not only display Gerber files but also to edit and save them. But none of this functionality is represented in the UI application. Everything is in the back in the lib library. So the homepage says Gerber is split into a core functionality library and a GUI portion. Developers wishing to incorporate Gerber parsing, editing, exporting, rendering into other programs are welcome to use Libgerbv. So I thought, oh wow, this is handy. Why is no one using this? If you look up Libgerbv on Google, you get the documentation, and that's it. No one's really using this library. So I thought, okay, there must be a reason for it. So I did some experiments with this library using C, and it was really a struggle to use it. And usually this should be suitable for electrical engineers, where the profession is not only software development but also hardware development, and they are not able to use Libgerbv, the C bindings, because it's really complicated. So we found a solution for this, and the solution is Ruby bindings for Libgerbv. I have two examples for you. The first example is adding fiducials for PCB assembly to the PCB, and the second one is penalization of a PCB. The resolution of the beamer is quite low. I hope this will fit. We start off with this example. So I'm not able to mirror the screen, so I have to look at it on my own. What we do is we create a new Joseph project. This is the same as what you get when you open GerbV. You have an empty project where you can add single Gerber files. So we start off with an empty project, and then I add some Gerber files to it. That's the same as you drag and drop or plus in GerbV, add more Gerber files, because GerbV does not know about what kind of Gerber file this is right now. I have some handy regex here in the end, which just extracts something like top copper layer, board outline out of the file name and then adds it to the project so that we are able to recognize the files later. So after adding all the files, what we do is we take bounding box of the PCB because we want to have the exact dimensions. And then I want to add a few fiducials. So, you know, fiducials is used if you mount the parts on the PCB. This is a camera system which recognizes the fiducial point to, for the absolute placement of the roboter. So I want to have most PCB assembly lines require this, to have at least 3 fiducials on the corners of your PCB. It's really important. And here we are adding 3 fiducials to the upper left, bottom left, and bottom right corner of the PCB. And this is all scripted. So if we change the dimension of the board, the bounding box will change, and then the absolute position of the fiducials changes accordingly. So in the end, I just iterate over all the fiducials I just created, draw them on a layer. That's done using the raw GerbV call. So the bridge class is used to take the bridge over to a Libgerbv. And then we're just saving all the files with fiducial and the layer name. So let's give this script a try. Ruby 2 fiducials. Performance is quite good because it's a C binding, so nothing actually working. So now we take our beloved application GerbV to check the result. I will take the solder mask, top layer, and board outline, and will invert the color of the top solder mask. And what we just did using this script is to add these 3 fiducials over here. And this is all done by script. So this is really fast. It's so you can run it over and over again. And the next script will do a panelization. So what I want is, I want to have this project on a new panel in 4 rows and 4 columns. So in the end, I want to end up with 16 PCBs on my panel. And I do this with this line, where I just say, okay, to the image, please add the image from the project and apply a transformation. And the transformation is basically just a bounding box around the PCB multiplied by the column and row where we are right at the moment. And because it's handy for our PCB fab, we create a zip file in the end. So what I expect by running this project is to take our Gerber files, read them, panelize so that we end up with 16 PCBs, and then save them within a zip file. That's it. We check the result. No. So I'm going to open the top layer and the board outline because it's sufficient to see the result. Here we go. And now the nice thing about this is we have a self-contained script with just one dependency. The dependency is GerbView. And what I really like and what I'm passionate about is to take software engineering techniques to electrical engineering. So now that we have the script, I thought, okay, maybe we can use this in continuous integration now. So every time I check in new Gerber files into my Git repository, I automatically want to have this panel ready for order. So let's see. So some of you may know, I think all of you know GitLab. And GitLab has a really handy continuous integration. And this continuous integration is run by a GitLab CI file. And what this GitLab CI file does is it installs, or first it checks if Ruby at all is available. Then it installs Joseph. And then runs the panelize job. And the panelize script itself is within the repository. And in the end, we create an artifact that's the result of the continuous integration job. And the artifact is named by this name. So what we end up is, we commit a new Gerber file to the Git repository. All the CI is run. And then, and that does not fit on the screen here, we can download the panelize job. So no more struggle with opening some UI application, just run the CI, which actually run automatically, download the zip file and send it off to the PCB fab. So we could extend this even more by adding vCuts for our fab, everything automatically. And it's, okay, these are the benefits now. I will go on with the presentation. So what are the benefits then? It's really easy to install. Just if you're using Debian, Ubuntu, whatever, aptitude get install GerbView. For the OS X users here, just brew install GerbView, and then you can actually use it. Next thing is no UI necessary. I think that's a feature because all the CAM applications, all the commercial CAM applications I know have a huge UI. And you have to do hundreds of clicks just to get a panel or add a few lines. So it's really complicated. And I prefer code much over clicking UI because I can check it into source control. I can actually see what it is doing. And this is really important, I guess, for hardware because we want to check if there's some change in it. Then it's battle proven. We use this binding within our company, and we do PCB manufacturing every day. So we never got an issue because of the binding or of GerbView. So and GerbView itself, I guess, is really battle proven because it's the last release is like 5 years old, and it really has great compatibility to the current Gerber standard. And it's high performance, but this does not really, I don't care about the performance because it's run asynchronously and that's fine. So what is the current situation about this project then? As I said, we use it in our company. Okay, 5 minutes left, thank you. We were able to pull down the cost of PCB manufacturing for low quantities in a domestic fab by 70% because of this library. Because all the tasks which are right now done by hand, we can automate them with this library. So that is also the reason why all the features are as requested by the company's interest. So there might be features missing which are important for single use cases, but they are not added yet. The coverage of the whole libgerbv functions is about 80%, but I have no plans to extend this, but because some functions are not, you just do not use them. Then the test suite there is a test suite, that's a good thing, but it's really, really basic. So it checks if drawing things work and if the Gerber file is properly formatted, but that's it. And what you might notice if you look into the source code, it was split out of a larger library like a few days ago, and sometimes you notice that there are some dead ends. So what I really would like is to have a new Gerber release, because the last release, as I said, is like 5 years old, and we have some recent changes which, for example, make it possible to rotate PCBs. Right now, the release included in the main distributions are not able to rotate PCBs, and some other features are also missing. And I don't get why there is no effort to make a new release. So if anyone knows that guy, because all the commits on the GerbView Git repository come from him, please contact me so that we can organize a new release. So if you want to support Joseph and you're not a software developer, just try to use it as much as possible, because this is, I think, really important for such a project. Then report issues if you have any knowledge about software development. The task I would prefer is to add some more high-level usage, because I guess the script I just showed was like 30 lines. We can shrink it even more. Then extend the RSpec suite. That's not a really nice task, but it has to be done. And some features are missing, like font text support. It's not possible to write text on your Gerber files right now. So just lines, circles, rectangles, and something like this. No text at all. So if you like this, there's a coupon code for my company. If you order PCBs regularly, cheapest price in Europe with domestic manufacturing. That's it. Thank you. Questions?
Have
Yeah.
you heard of Gerb merge?
I heard of Gerber merge. I used it like half a year ago. So the question was if we have heard about Gerber merge. What I do not like about Gerber merge is that it implements all of the Gerber stuff on its own, and it's not really complete. So there are situations where it does not work. And from an open source perspective, I think it's much better to work on one project to support Gerber than on different projects. Next one.
Andrew, it was 19 hours ago.
Yeah, it's pretty active. That's the reason why I don't get that the latest release is from 2011.
That's the difference.
Yeah, look up the Debian packages, so Ubuntu packages.
Just looking at the repository, most recent.
But it's really, really hard to compile. I tried it. The make scripts and all the auto-configure script is really outdated. So I wasn't able to compile the current master head at all.
You should try the mailing list. Have you tried the mailing list to us?
I tried the mailing list, but when I last tried, there was no effort with this gem. Maybe now it's more successful to give a reason, because I guess the reason why there is no new release is that as GerbView itself has no editing functionality, there will be no release for Libgerbv with editing functionality, because if it's not within the UI application, no one will use it. So
You can delete elements.
yeah, that's it.
Some kind of editing.
You can delete elements,
Yes.
but the Libgerbv has much more functionality.
So
There's a question over there.
Yeah, I think for some applications you have animation in your PCB tool. For example, if you do a panel of multiple boards, and for testing you want to test them all at once. So you want to have like traces on the panel, so that you can just plug in your whole panel into a test rig, and all boards get tested at once. and then you can handle afterwards. And that case, I think it's definitely required to do the penetration.
Okay, so the question was if I do a panel where all the projects on a panel have overall functionality I want to check. I've not seen that use case of a panel. I see it much more from the manufacturing position, and there the point is all the time put as much projects on as a really small place. That's it. One over here.
Do you use the scripting also to check Gerber?
I use it, for example, to count drills. You have to find single subjects to check on. For example, what an idea of mine was to do some checking if, for example, the paste layer changes. You could create a hex digit out of the paste layer and then check if it changed, so that you know if you have to do a new stencil or not. That might be an idea. But you can run aspect tests on your Gerber files. That's right. One over here.
Yeah, I noticed right now it looks like you're just supporting scoring and breaking. Yeah. So there's no like margin between the boards like the round. Not all boards are square, and you're not going to always be able to snap. You can't snap.
Yeah.
So
Yeah. The reason why there is no space between the boards is I wanted to keep the example script as simple as possible.
Okay. Can you do that with script?
Just add a little spacing, so you know.
Like more X, Y margin, more margin between the X and the Y boards.
I mean, it should be scriptable, so you
Just add plus and measurements are in inches here, and you have margin.
Okay.
That's it. That's a nice thing about scripting.
Right.
What about the mouse byte? Instead of V-score, adding.
You have basic drawing functionality. Use this. Just draw a few lines. What we do is we usually mill the PCBs, so we draw a milling pass.
Right.
But creating the milling pass is another topic. But adding the milling pass to a Gerber layer, that's the task of Joseph. One question over here.
Yeah. What about the information for the pick and place machine? So if you get a panel out of manufacturing, I guess you send the whole panel to assembly, and
Yes.
then how do you get the updated coordinates for all the boards you placed on the panel?
Joseph is not able to process pick and place files, but my advice is to write down a file with the coordinates given here, and then just add them using Excel. I mean, it's Ruby. You can just write a file and have the top left coordinate of the according PCB.
Gerber will load pick and place files, and that's not part of the binding, or is that not part of the version built against?
I think GerbView has support for pick and place files, but I did no research on it. And as pick and place files are somehow arbitrary, so everyone has different pick and place files, I think it's really hard to get a binding for it.
Okay.
That's it. Thank you.